Good afternoon, everyone, and welcome to the 5th Online Energy Efficient Building Seminar. My name is Hugh Whiriskey. I'm the Technical Director at Partel, and I'm really pleased to host this session in the webinar series. First, I'd like to introduce the EEBS event. The key theme for this year's event is Empowering You for nZEB. The event is part of a collaboration between some of the most knowledgeable experts in the low energy building industry, practitioners, educators and communicators, and Partel in partnership with CORE, Daikin, Nordan and Harmony Timber Solutions are responding proactively to the recent changes in building regs. And during the 4 weeks of seminars, we'll be able to provide you with an integrated approach to sustainable building design and construction, all in accordance with nZEB requirements. The CPD Webinar Series will present a range of envelope and building performance solutions that aim to help you meet the nZEB standards for both new build and retrofit projects. You're welcome to join us next Tuesday for the final seminar and the plenary session. I'd just like to take a moment to thank our media sponsor, Passive House Plus, for their kind support. Passive House Plus are really an invaluable kind of ethical, high quality source of really technical information, and they go really deeply into the projects to be sure that everything is I suppose presented in an accurate way. And yeah, a huge resource, so something we can all be glad to have available and hopefully support as well. So today, the 5th CPD seminar is presented by Martin Williams. He's the Contracts Director at Harmony Timber Solutions. Martin will be talking about timber frame structures, offsite nZEB compliant systems, factory quality control for construction and more. Martin has worked on projects in Ireland and the UK and has led developments in the industry that have impacted on the quality control and the quality of the final delivered homes. His career has been completely focused on timber frame technology and its systems. Just before I hand you over to Martin, there's a Q&A box on that we can use to populate during the presentation. At the end, we'll take you through all of those questions. So now I'll hand you over to Martin, who will introduce Harmony and continue the presentation.
Good afternoon, everybody. Just to clear, you can see my presentation, clear one screen, Hugh?
Yep, looks good.
Yeah, just thanks to everybody for attending. My name is Martin Williams. I'm currently Director with Harmony Timber Solutions. These are my contact details, but we can share these at the end of the presentation, or if anybody wants them, they can contact me directly. Just a brief company background about our company, who we are. Harmony, we were established in United Kingdom in 2011. We were manufacturing in the southeast of the UK in Canterbury, and we established then and set up back in Arklow, County Wicklow in 2015. A fully owned Irish operation. We've got 100 staff, both directly and indirectly, which we're involved in site fitting teams. And our commitment to offsite site sustainable construction, we've just submitted a commencement notice for a new purpose-built factory, so we can add probably to our product development and what we can supply to the market to enable us to future develop our systems. Our products, which we supply to the market currently, which would be our timber frame structures, which would be timber frame walls. We also supply roof structures, which would include feature trusses, fink trusses, attic trusses, and we also supply posi joists, which is more commonly known as system metal web joists or engineered joists. So today's agenda, what I really want to go through with you, nZEB standards and what Harmony Timber Solutions as a company, what we offer to the market for this. So I'm going to go through walls, which is our timber frame walls, our floor structures, and our roof structures. Just our end-to-end process of literally us dealing with customers and dealing with clients. Once, look, we would tender for projects, and there'd be before our order is received, to and from with our customers, really understanding what they require from us and what we're able to provide to them to meet their expectations. So probably once an order is received, we'll go through it. And we have a whole in-house team of designers who will go through each project, specific project, work on it. We are process driven. So we're all operating our factory controlled environments, which is NSA audited, but in the factory, and our processes of how we do our design, how we go through the details, how we transfer that detail to our customer, how we transfer it to a site. Load and dispatch, because we'd have to meet such tight schedules on site, we would have an organized area for load and dispatch. So our manufacturing process is all geared to ready on time to have it on site. So all our items going to site, our walls, our floors, our roof trusses, because we've such tight deadlines to hit on site, and our products are so large as well, that we're able to hit them on time deliveries. Our on-site, then we also fit our products. So we have probably in excess of 40 people on site, which would be all part of train directing teams. And most of them teams will be between 4 and 8 people, depending on what we're doing for each specific project. Just then, I'm just going through our wall sections. We generally would have 3 different type walls that we would supply regular to the current market. The 0.18 wall, which we call our urban wall, will be generally geared towards large developments who would mainly have gone through their BER and would want to meet just the minimum backstep value, which the minute is set by 0.18. Our 0.14 wall, which then would be for, say, medium density builders, self-builders, people who want to exceed the current building regs and want to build a product that'll give them air tightness and insulation. This probably will be our most in-demand wall at the minute. We're probably, generally over the last 3 to 4 years, this will be our most used wall. So most builders at the minute are conscious of exceeding the current building regs. And we'd have our 0.12 wall, which we call our exemplar, which mostly would be targeted towards one-off customers, people building towards passive style developments and that want to exceed current building regs. So this will be our 0.14 wall. So that's the one I'm going to focus on today with you. It's to go into more in-depth detail about it. I have a short video just on this that shows our build-up of it. So our structure will be a 38 by 140 stud, which we'd full fill with insulation. On the external face, it will show the positions for the wall ties. Most of structures we're supplying out to would have an external block or brick on the outside. The internal face, we're full fitting a PIR, which will give us a full thermal break along the inside of the wall. We will also fit our insulation. All our insulation is factory fitted. All our air tightness membrane is factory fitted. We have a 35mm service batten on the inside of the wall, and our air tightness is clearly visible on it. So if any damage to it is easily visible and easily fixed on site. Just then to look really detail into our wall, our insulation, which is in here, is all factory fitted, our wall the sole plate will be fitted on site. So when we're developing these walls, we are looking at structure, and really nearly all of our walls will fit with 300 mil dead building coming out of the ground. So we're conscious of developments that they want to get a high U value, but they want to increase the size of the wall, because increase the size of the wall could mean the difference of maybe 1 or 2 units on a site if they are building terrace units. This insulation is factory fitted. This insulation is factory fitted. Our air tightness layer, which is here, is factory fitted, and we will fix this then down to the structure, so we achieve good air tightness through these junctions. The service batten, again, is factory fitted, and it's left ready on site for the plasterboard to be fitted. And just going through our U values of it, we are using multiple components to achieve the U value of 0.14 in our wall. So our benefit would be multiple components, which would be making up of external membranes, which will be foil-faced, and internal membranes, which are foil-faced. So we're using probably the best of insulation and membranes to get our U value. So what we're trying to get is a cost-effective solution to the market that's not increasing sizes of walls or having an increased cost to it. Also, because we've such a range of build-up of components in it, we have done a condensation risk analysis on it, which is independently tested, which shows that there's no risk to the moisture build-up within our walls. It's tested through with a woofy system, and what we're doing, this curve denotes winter, summer of the moisture within the wall. And this model is actually done as if there's a penetration in the membrane, which can happen on site. So it is allowing a buffer for any moisture that gets into our wall. So we're sure that there's no condensation risk within our wall during or after construction. Then we would generally be detailing accredited construction details, how we can improve them, what we're doing in our systems to make sure that we're giving a better product even than current building regs to improve that ACD. And because we're also thinking of fabric, insulation, air tightness being factory fitted, this currently is the current ACD for an external wall and an internal wall junction. And so the air tightness layer is running right through, the insulation is fully fitted, but to improve on that, this is our solution. So we're making sure we're factory fitting this insulation. We're also, our studs within the wall provide our structure, but we're also fitting a full run through of 50 mil PIR on the inside of the wall, which gives us a full thermal break. But as well as that, we're also, our air tightness is fully fitted right through. We're able to protect that junction with a stud, that we're not ending up getting, you know, if this wasn't factory fitted, there is a high chance that the air tightness layer could be forgetted to be fitted on site. So then you have room for error when it's been fitted on site. So by doing this all off site and within our factory, we're reducing any error or fitting or just someone just forgetting to fit a specific, but it's a critical item to do with air tightness and to do with vapor control. So then our fabric first approach for all our buildings, in our design process, when we get a project, we'll do a full design review of each project. Lot of when we get an architectural drawing, you know, we'll have to incorporate both structural and architectural issues that will arise. So specific would be, you know, our critical junctions. Some of the time we'd have a lean-to roof on the rear of a building with the blockwork isn't on the ground floor, but is on the first floor. So we'd have to incorporate into that structural elements to carry that blockwork and our timber frame. But we also, we want to try and eliminate cold bridging at them points, and we want to make sure that our air tightness layer is passing right through. So as our fabric first approach to the design, we're going through all these details and agreeing them off-site before they go to site. So everything is done, agreed and detailed by our design team. Also, our critical junctions where you would have a wrap around our floor joists, where you'd have flat roofs coming in onto 2-story sections. All them we'll be going through in detail and make sure we have the best possible outcome when it gets to site. We'll also incorporate into that ease of fitting. You make sure the structure is supported on it. Controlled factory purposes for our manufacture. Because we're working in a factory controlled environment, our ease of doing stuff, with Irish weather, Irish conditions, it improves our product offering. All our to manufacture timber frame, to manufacture roof trusses, to manufacture metal web joist, we have to be NSAI approved. That approval doesn't just last; it's also an audit every year, both in the factory of our systems within the factory process and our design process. All our products then we use within our manufacture are all CE approved. Also with our controlled factory process, because we're actually using what we would call a computer to saw process, every item is precision cut. We're using precision manufacture. And because we're off-site, we're able to optimize our use of materials, which it also is leading to less waste. So we have less waste in the factory, and because fitting, insulation, all that kind of stuff can lead to a lot of waste on sites, which again is causing environmental impact. Our process then continues when we arrive to site. So all our walls are pre-manufactured, arrive to site completed with our insulation in it, our air tightness, our service battens, and you can actually see from this slide how, when the wall is stood up on site, how it looks from the inside. All our crews are fully trained in our systems, so they're the critical junctions where we'd have to fit membrane on site to wrap around. They're all trained in that, all our full system, so we're ensuring quality is again on site. On-site services, the electrician, your plumber, so because the membrane is already fitted on our external wall, the electrician and plumber are fitting inside that, they've less chance of really having to damage our membrane. And again, we'll be incorporating all where external wall joins to external wall, where internal walls joined, there will be a ground there for a plasterboard so it can be fitted. Our air tightness process for our openings, this is just basically on our external window or door openings. As part of our design process, we would liaise with an architect to do with brick dimensions, oversale of brickwork, window sizes, what the window manufacturer wants for tolerance around them. General tolerance fitting around all our windows are 10 mil, which then allows us to get a complete wrap of our membrane right into our windows here. So there's our internal membrane here. So it fully wraps right back into the window. And we use a Connexo tape, which is a twin liner tape that the tape is only 12 mil onto the window. So then when the plasterboard is fitted to the window, it's fully covered. So this is allowing us to get a full airtight envelope right wrapped around to some of your junctions, which would be your external windows, external doors. Party walls, again, it's not just all external walls, internal walls. The party walls are all factory fitted insulation. So our insulation fitted in our party wall, our air tightness membrane fitted in the party wall. All this is done within our factory, and our plasterboard is also fitted in our factory, which then we will fully wrap these for fitting on site. So we will fully wrap these to make sure that no weather really damages our plasterboard systems on the site. Then our floors, which will be our for our timber frame structures, we will manufacture prefabricated floor cassettes. This enables us that again, we're going through our design in-house, we're manufacturing in the factory. The structure, the webs, the size of the joist, the spans, it's a fully engineered system. So our web widths, our web widths for the timber widths for our joists range from 72 mil up to 147. So standard with our floor cassettes, semi-detaches are about 5.5, 6 meter span. Most of them we're actually able to clear span. So it's reducing the need for internal low burn walls within the structure. These arrive on site ready for fitting. We will also fit insulation within some of the junctions of our floor panels to make sure we're reducing cold bridging. Our OSB is all factory fitted. It's screwed and glued in the factory. So that's enable us to, there's a health and safety issue with it, so it reduces the actual activity of really working at height. These arrive onto site for lifting off our lorry with a crane ready for fitting straight in onto our ground floor walls. Just on our floor cassettes, because it's a critical junction, we need low burn for our walls to sit onto our floor cassettes. So we'll actually wrap our membrane from the inside right round our floor cassette and right back in. So again, it's given us a complete airtight envelope. And again, because this OSB is arriving on it, it reduces your issues with working at height from them. Also within our floor cassettes, we would be trimming out a standard for stair ropes, all that. So all that is agreed again with our design team offsite. Our roof structures. This is a standard cold roof. With our cold roof, I would mean say a standard fink roof where the insulation is going to be fitted at ceiling level. Again, from our walls, we're able to join right up across our underside of our roof trusses. And we will also be, so the difference with this, our walls and our roofs, the air tightness is fitted on site with our roof structures because the roof has to be spread. We can't make up a full roof and put it on a truck and transport it out. So all the air tightness is fitted on site. We actually use larger rolls. We'll use 3 meter wide rolls for our air tightness on the ceilings, which again reduces tape and reduces connections of it, which is again is reducing the errors for joining membrane to membrane. With this as well, we're also fitting a service batten on the ceiling, so the electrician can run his wires round underneath the service batten, so he doesn't have to perforate the membrane to drop his wires down through it. Probably the only place this membrane will be perforated will be for services have to go up into an attic, but when they're kept to a minimum, they're easier to control on site and they're easier to get them really completed and airtight. You can see in this house, it's a semi-detached house, so we're actually able to fit the full ceiling on this house before we stand the internal walls. So again, as part off to our design, our offsite design is making sure that we have enough tolerance left to fit the battens, to fit the plasterboard, all that, and so there's enough room left to stand our internal walls. Again, a cold roof, just the U value of a cold roof. This insulation we don't fit. This is generally fitted on site after by a main contractor because they would have water tanks to go up into it, and more now we're seeing more PV inverters fitted up into attics. So then the design of walkways, the access up into them, health and safety has a big impact now up in attics. And so generally this insulation is the last thing to be fitted, but we have already fitted our air tightness membrane underneath it and our battens allow for services. So this is our build up of our U value, and we're using our just standard glass wool to be fitted here to achieve a very low U value. Our warm roof, which would be our slope roofs, our attic roofs. A lot of our warm roofs, we're actually fitting with top hat trusses and purlines, which allows us a loose rafter then down here. And we actually, with the warm roof along the slope, we will fit this insulation because you can't, it has to be fitted prior to fitting our air tightness membrane and any of our insulation, then we fit on the inside on the room void. Again, we'll also leave a service batten on the inside for fitting of services. And then just a typical build up of a warm roof, we're achieving 0.12. So again, we're given a full thermal break along the inside of our structure, which is 50 mil insulation on the inside of it. This actually build up is again to do with fire. There's 2 layers of plasterboard in this. And then we're fulfilling our rafter with insulation, and we can do that because of the membranes we've available to us on the outside of the structure. Our quality control, which I want to go briefly through with you. Our quality control first in the factory. We have strict controlled environment in our factory. We would have regular checks that would have to meet our NSAI standard. And again, all them checks are audited yearly. So each project we do, we have a certain amount of checks to do with them. Because we're in the precision manufacturing, we will be checking dimensions of walls, we'll be checking window opes, door opes as part of our manufacture process. All our materials, when they're being delivered as part of our NSAI checklist, we are checking incoming materials for moisture contact, and we'll also check for specific tolerances. And again, that will lead back to precision manufacturing. We have to have a specific tolerance for manufacture of the panels and for even our timber coming in. This helps us really to get better quality panels. It also helps us get reduced waste from our products. So in our factory, because we're able to optimize all our material, we're able to reduce our waste. Our quality control on site. Because strict site conditions, look, it's a harsher environment to work than a factory controlled. We have developed our own on-site app. So on that, we give access to all our erecting crews. So they're detailing what they're doing on site. All our site erecting details, which will be our timber frame details, the site pack of how to put that specific timber frame together, which would include all the fixing details, any specific details to that project will be all uploaded onto that. We also send laminated copies of this to site as well, so they have them to hand. All our erectors' health and safety details, their safe pass, their CSCS cards, manual handling, working at height, slinger banksman tickets is all uploaded onto this app as well. We also to achieve BCAR an ancillary cert, we have to be making sure we're doing checklists as the building is being fitted. So all our checklists on them are relevant to each project, but also with that, we actually have what we use pictures, and on them pictures they're actually timed and dated relevant to each project they're doing. We also provide on-site access to this app. So anybody that's checking quality control on site, whether it's an ancillary certifier coming in, whether it's someone from that building company wants to check it, they will have access to the app and can go through a history of all the projects that we've fitted on their site, and also then they can also see what other projects we have uploaded on it that are due to arrive to site. So all this will actually feed on to what the BCAR on site. Just a brief on our fire tested. We have gone through our thermal, our air tightness products, but also our systems are all fire tested EN 1365, part 1 for walls and part 2 for floor structures and roofs. So there's probably been confusion in the last while over what plasterboard has to go on walls. So here we have our insulated wall, we have our insulation again, our air tightness is here, but a critical element to make sure this conforms to the regulations is the plasterboard. And what we have been finding is that the confusion of what size plasterboard has to go, what size screws have I allowed, what size centers they have to be fitted. So these are just standard details we have from the fire tests that are easily available for on-site for checking and to know what product has to be fitted in what situation. So this is for our walls. This is for our posi joists, which is 15 mil. So then arrives to site or 80 mil OSB screwed and glued in the factory, positive joist. So then the fitting of the plasterboard is easily obtainable, the details for it, what size screws, what centers again. We also not just test our components as individual items, we're also starting to do combined fire tests. So our critical junction between a ceiling of a floor and the junction of a wall, which is this junction, we have completed fire tests to make sure that these conform as well. So this is actually the test that has been built in Warrington Fire Research Centre. This is it before when it was completed, and this is it waiting to go in actually to the fire test rig, which is down here. Then this is just our roof trusses for 3-story roofs, cold roofs, warm roofs, any erratic trusses. Again, all the fire tests are completed for them, and all them details are available. Our alternative products, what we're offered to the market, we also supply to traditional build market, which we will supply roof trusses. We'll supply roof trusses to traditional block brick build, to ICF metal frame buildings. So we're not just only supplying to our timber frame market, we also supply traditional build. So any range of trusses, large spans, we're able to do what we do for our timber frame customers with our traditional build customers. We also will provide feature trusses, which are here, which some of them we can design as just for looks, or we can actually design them for structure to split spans along large rooms. This is one that we actually provided to a project. It was a timber frame project, but in this design, we're also incorporating our air tightness, our insulation, and what some people would have forget, the build-up of the insulation inside in the room after can also impact on how the visual effect you'll see at your finished product. So we would actually set these down from the structure after, so the client has full visibility of this when it's finished and plastered and painted. Engineered joists, again, our range of depths, which our standard depth will be we're supplying to the market at the minute is 253. We also have that available in a 302, which in probably most people will be a 10-inch joist and a 12-inch joist. And the widths of the webs, which I referred to earlier, which is these. So these are 75 mil by 302 joist. We also have them available in 97, 122, 147, and depending on the spans of the project, we'll design specifically to suit that, to give a cost-effective solution. It is a fully engineered product, so all calculations, design calculations, engineering are available for any engineer, which will, again is for BCAR. The benefit of these joists, fitting your services, we're seeing more and more heat recovery ventilation systems fitted. Like there's more and more electrical systems, Cat5, Cat6 cables. So where it would have been standard, your one pendant light in a room, there's more and more electrical services, mechanical services being run in these, and these have a massive benefit to it. A lot of, any of these systems, if you're using standard 9x2 joists, you'd end up having to put in a suspended ceiling. Just key customers who we are dealing with both here and in the UK. Bellway, we supply in the UK, Cairn Homes, which will be here. McCarthy Stone in the UK would be generally our main market with them would be retirement living. So they would build some of their projects 2-story, 3-story high using traditional methods of construction. But generally their top story, which they would class as their penthouse suite, will be set back in from the edge of the building. So because our timber frame is so lightweight, it's a very feasible option for them, so to fit the timber frame on top. D-res properties here, we have supplied them, but roof trusses, metal web joists, and they did do, I think in one of the core presentations, the Silken Park job in near City West, we supplied trusses and joists to that. Monami Construction, who we supply timber frame to. Glenveigh Properties, we supply timber frame. and Persimmon in the UK, who we supply timber frame, roof trusses. And probably the UK, we've probably a range of products that will deal with party walls. So they're manufacturing offsite party wall solutions for attics. And our commitment then to our offsite sustainable construction, we have submitted a commencement notice due to COVID, which we should have had in a few weeks ago. We are probably just slightly delayed, no more than anybody else at this time of the year, for 2 new factory purpose-built units for 4,000 meters squared. So in them we'll be incorporating manufacturing lines, fully automated lines. We have acquired 27 acres of a site here in a scenic setting, which works well with us with timber and timber suppliers. So that's my presentation to you. I hope I didn't hold you up too long.
Yeah, thanks, Martin. That's fascinating. I guess I've been using timber frame I was thinking about it while you were talking, for 20 years now, or close on it, which is making me feel old, but it's amazing to see how far it's come. So yeah, the move to systemize the installation of all the various parts, it's pretty different from 20 years ago, but I guess I see a lot of that stuff internationally as well, and it's also it's nice to see where Ireland is positioned internationally in that way. It's really kind of, yeah, it's really high quality. Just before we get into the Q&A, a short reminder of kind of where we are in the seminar series. We will have a final plenary next week, just after the ventilation for nZEB system. So hopefully everyone can join, but that will, where Jeff in Passive House Plus, he'll be taking us through some insights of the impact of nZEB so far and where we think it will go as well. So that's next Tuesday at 1 and 2 o'clock. So Martin will start on the questions. Lots of interesting ones. I've seen them coming in directly to me and in the Q&A. So what's the approximate price difference between a 0.15, 0.14, 0.12 for wall build-ups? I guess, is there a percentage kind of guide that you would see those changing through?
There's probably no set percentage guide of the changes from them. And it would, like, we actually analyze and price each individual project that comes to us. So the insulation, the size of the project,
Yeah.
There's no real set percentage guide of the cost increase from one to the other.
So probably
but
best
we have had
price
different
the
customers
options.
really ask for that option.
Yeah, okay. So you're open to pricing different options for people. What is the maximum vertical span that you can go with the wall panel without horizontal noggins to maintain the U value and reduce bridging? Are the U values based on having no noggins? So I guess that varies as well per project based on the structure.
It would vary from project to project, because we do a full structural design on it. Like, it would depend on the sectional size of that timber.
Yeah.
For vertical, like, introducing noggins, it's probably mainly down to our structural design on it for wind load.
Okay.
So that's if fitting vertical noggins, we actually try and eliminate them in it, because it slows down our process with in our manufacturing.
Yeah, so probably.
So if for all possible, we'll go with a bigger sectional size of timber to reduce them noggins.
Gotcha. Where do you source the wood? Irish wood, I guess, wherever you can get it these days, from what I hear.
Nearly all of our timber is imported, because we're using a specific structural grade. For our roof trusses, for our metal web joists, we're using a TR26 timber, which is a higher grade. Your standard grades would be C16, C24. TR26 is a higher grade than them too. So that's an imported timber, and to get that structural grade, it's coming from slower growing climates.
Yeah, not something we can produce locally really for that. What is the maximum clear width for span sizes? I guess that relates to the floors.
Again, clear span would, it would, sometimes we can be limited from an architect's drawings. What's the sectional size that's really achieved for planning? Like sometimes we'll get a drawing in and it'll be drawn with a 225 joist. The first question we ask, can you go to 253? If we can use a 253 joist, we can achieve a better span. If we can use a 302 joist, we can use a better span. But also we have a range of timber sizes, 72 mil. We can increase the sectional size of timber to get that span. But we have, I think we've had a project a couple of months ago. I think he had 6.5 meter span of a joist. So we have different options available to us: increase the sectional size of timber and reduce the joist centers.
Yeah. You've answered the second question.
To add, all our joists, all our metal web joists are 400 centers.
Yeah. Okay.
So we can reduce that to 300. Like if you take a 300 mil, 300 center joist with a 147 wide section, we have a fair, span we can go to.
It can keep growing. Yeah. So interesting. It's a good question. Well, firstly, what size are the service battens, and maybe why?
Our service batten is a 35 mil batten, mainly because for the services to go into that, it's probably the best size available. Like some will say, well, why not use a smaller sectional timber? It's cheaper. But if people look, some developments are still fitting radiators. And for them to bring that service up for an insulated pipe in it, it'll fit within that 35 mil service zone. Yeah. Probably the only pipe that would cause issues would be where someone is bringing in a flow and return for a heat pump. But generally, that'll be in a utility area or in a kitchen area, and locally that it can be battened out, to make sure they can achieve that within the service area.
Yeah, and I know from our side, we know that it helps to protect the airtight layer, having that kind of depth as well.
Yeah.
Is timber frame being used in any non-domestic projects? And if so, what would be the key considerations as opposed to domestic?
And we have a commercial one, which it's still under construction, a nursing home, which we've seen probably more and more inquiries with them. And probably the key at the minute to nursing homes is probably the main key to it is it's a faster build, but also because they're a large commercial building, ease of heating them, controlling the inside temperature for them.
Yeah.
And with that, because all our systems are fire tested, a commercial building like that, a nursing home, your external walls have to meet 60-minute fire resistance. We have the tests already done for them. The internal low burn walls again would have to hit 60 minutes, so they're all done.
Yeah. Two questions together here. What insulation would you recommend or most recommend for your products, and have you encountered issues with fire officers regarding the use of PIO insulation within the last year?
We use it because we're using a range of insulations to achieve probably a cost-effective solution to our end user, which is the customer. Some of the time what we're using is availability of it, but we're also conscious of, like, some of the glass wools that are your older style of glass wool, their use for even fitting in factory for health and safety we don't use.
Yeah.
Okay. The question regarding the PIR from the fire officers, the question has arisen with them, but because our wall system has been tested with the PIR in it, we know that it conforms to the regulations.
Yeah.
So and that's probably one of the reasons why we tested the wall and the floor junction. Because
I guess that's kind of the thing, isn't it? The system is actually tested as a combined part for that detailed fire test you showed us earlier.
Yeah, it's a fully tested system, and like any of the tests that we have completed as an industry, the DOE were involved and they actually attended some of them tests. So and any of the tests, some of the tests, all the tests were done. We fitted sockets in the walls. We fitted lights, pendant lights, and ceilings. Like we've tested them to make sure that probably, well, as many eventualities that will occur on site are allowed for in the test.
Yeah, it's important for people to know that it's quite a real test that's carried out.
Yeah.
Can you increase the structural capabilities if it's required to? I guess that's a fairly easy one for you.
Yes. Well,
yeah.
It depends on what situation it would, like the structural capabilities of the timber frame. Each individual house is designed to that project. So we're seeing more and more larger openings, and bifold doors seems to be the buzzword, and large openings and bringing outside in. Look, it's not ideal for any structure, but like sometimes in that we have to introduce steel wind portals to make sure we can achieve the strength required in the building.
Yeah. Do you have a typical details of thermally modeled psi values that BOR assessors can use?
We have some of them available, yes, but again, some of the ACDs for timber frame are under review at the minute from the DOE.
Yeah.
So, but we have them available if BOR assessor needs them.
Yeah. What is the insulation upgrade that you use to achieve the 0.12 U value?
That's a trade secret. No, actually, again, we're conscious of it cost-wise, and you know, when we are developing these wall systems for ourselves, we're looking at, you know, the builder or the person that's building it. You know, the real difference is it's a wider timber frame within the wall, wider timber stud, and increased size of the insulation.
Yeah.
So it's effectively a wider wall. Our 0.12 is a wider wall than our 0.14.
Yeah, and I guess it's unlimited in that way. You can make it wider. There's cost implications with
like
that.
The range of mineral wool available to us are anything from a lambda value of 0.044, 040, 034, 032. So the lower lambda value we put into that wall, the better the U value we achieve.
There's a question here on the WUFI calculations. I think you covered that one in the slide, that they are tested in WUFI. Is it possible to use different kinds of insulation in the superstructure? You've pretty much covered that one there as well, Martin, that it can vary.
It can, like, this like some people will come to us with a U value they're trying to achieve, or a build up that has come from a BER assessor or something that they're trying to achieve, and not like some insulation providers will detail all their products within a wall, whereas because we're standalone, we pick and mix to achieve the best U value result for our customer.
Yeah, it's ideal. Where exactly is the air tightness layer in the wall detail? And look, that's probably an early question. I guess it was covered. I guess it was, thanks Colin, I'm speaking a little quietly, I hear. So the air tightness layer, I guess you've seen covered in the later slides, that it's inside the PIR. How do you connect the first floor walls to the decking? I'm guessing by the decking they mean the floor. So how do you deal with the first floor walls to the floor cassettes?
That's a structural, really connect them structurally.
I suspect it's a question about air tightness, actually, or maybe that's just me actually thinking that way. But
we use butyl mastic, which actually won't go hard and crack.
Okay. Within the service zone, fixings may penetrate the airtight membrane. Have you developed any solutions to minimize air loss?
Tell the electrician not to penetrate it.
That is it, isn't it? That it needs to be integrated on site.
We do have situations on site where it gets damaged, or with quality control on site. It's not just us when we're fitting the product. We also try and educate the on-site foreman personnel, the electrician, the plumber, like some of the time they might have somebody that's not used to the air tightness membranes and will, you know, to no fault of their own, puncture it or damage it or cut it. So we have repair, you know, available to be able to cover all that.
Yeah, no, that's clear. And I know the slide I covered in my own presentation last week or the week before, we had seen essentially a perfect frame delivered from similar type of system to you, but it hadn't that due care taken on site, and it didn't matter how good the offsite offering was if everyone else on site isn't willing to buy in to the airtightness.
Just with part of our on-site app, we actually go around and check our membrane when our fitting crews are completed, and we actually take pictures. So it creates a record that the membrane has been fitted correctly. So then generally on site, before it's slabbed, generally someone on site, after your first fix elements are fitted, we do recommend that it's rechecked again, because look, to no fault of someone, it could get damaged from a pipe from.
Yeah, and that's our blower door test, right?
Yeah.
That'll help with that. So a couple more questions, Martin, or a lot more, I should say. Are the internal battens puncturing the air tightness membrane, and how is that dealt with? And maybe that's one for me, Martin, that the membranes are all constructed with a polymer. When that polymer is heated, when the screws or nails are pushed through it, it self-seals. So that isn't a source of air leakage. How do customers fit spotlights in a flat ceiling if it is a cold roof and the insulation finishes above the airtight membrane? I can probably take that one again, Martin.
Yeah, that's what
it
your
is.
your airtight box.
There is proprietary solutions for that can connect to the airtight membrane and allow room to install the downlight or whatever size downlighters there are.
Just increasing your envelope up around that light.
Yeah.
Yeah.
What kind of sound attenuation can you provide in the floor cassettes?
With residential, there's actually no requirement for it.
But I guess it's a little bit like the insulation. I know in my own experience, you can go as far as you want. You know, you can introduce quite a bit of sound insulation if that's
we're
the
actually
request.
finding in the last while, we're actually recommending to people to fit. There's no requirement in the building regs to fit insulation in a domestic house between your floors, between your walls. But because people's lifestyles and how they're working is changed, like people working from home are saying, "Oh, I'm hearing noise from the kids upstairs. I'm hearing them next door with the television on." And they've lived in the same house for years, but it's only now because people are working from home that they're actually, you know, they're saying, "Oh, why is there noise in between my floors?" But we actually recommend to people put insulation in between them.
Yeah, so it's an option.
Yeah.
Do you target passive house airtightness? So if a project is complex with a recessed balcony, can you achieve 0.6?
Again, it will be down to detailing them junctions, like a recessed balcony back in, so you have a flat roof back in. So the construction detail of that, the air tightness, even the thermal breaks through that will be critical at design stage. So that will be for each project specifically designed. Like we did a project, it was down in Galway, domestic house. There was flat roofs. There was 2-story sections with cold roofs. There was vaulted, fully vaulted ceilings in the kitchen living area. You had corner windows, and you achieved 0.7 air changes.
Okay, yeah, so yeah, 0.6 is pretty close. And I assume, was that a certified passive house or just a standard?
No, it was a standard, but he was building as best practice towards passive.
Yeah, very good. Is there any plans to commence manufacturing of CLT panel systems in Ireland that you're aware of?
At the moment, I'm not aware of anybody due to commence.
Yeah. Have you paired with a timber cladding company or metal cladding for all timber walls? And this is to avoid brick or block. And is there any structural implications with that?
Structural implications, we'd have to be aware of that at initial design stage, because even the block work at the minute is just the cladding. It's no structural element to ours, but it actually, for wind loads, it is incorporate into our design for wind loads on the timber frame. But there's no restriction for us to say to put a batten system on the outside, a cement board and render system on it. But again, it will be back to structural design of our kit.
Yeah. Has cross-laminated timber ever been considered for timber frame? And I guess this could be for wall panels or for the structural beams.
We actually use glulam within our structures. We would use, like, we're timber frame suppliers, our preference first is timber. So in a lot of our structural beams within and floors, within and roofs, our first option will be to use glulam timbers.
Yeah. Do the homeowners have access to the information contained in the app? So for sign-off, certs, that kind of thing?
Yes.
Yeah, that's brilliant. It's really interesting that.
Like it depends. Like some of them will use the opt-out of the BCAR.
Yeah.
So they don't require that. But then we'll often say to an architect who's dealing with that, or an engineer who's doing the check-in on the site, here, these are available to you anyway.
Yeah.
Because some of the critical elements that can't be seen or can't be checked after, we would have records of them.
Why do the party walls have plasterboard installed in the factory? So I guess people are saying that that's different to the external walls.
It would be under a directive of from the DOE, but also it is because it's such a critical element of fire within in semi-detached houses, that because we're fitting in a factory controlled environment, how they're fitted and tolerances and fixings is all controlled by us.
Yeah. Is it possible to use timber walls with EWI?
EWI?
External wall insulation. I know it would be.
It would be, but again, it'd be back down to your condensation risk analysis, your structural design.
And I think probably in Ireland, there's a reason people use rain screens to help provide a second layer of protection should there be any issue with EWI. So I know that for me, that would be a preference to lean more towards a rain screen.
Well, I'm in IS 440, which is our standard for timber frame. You have to provide a cavity.
Yeah.
And mainly is because of the weather conditions.
Yeah.
So if you are using an external wall insulation, you would have to probably put a batten or some kind of a system outside to provide a cavity. So any driven rain that comes in from your external cladding or finishing isn't getting directly to your insulation to get, to be drawn back into your house.
Yeah. Question here, mineral wool versus pumped cellulose? Question mark, I guess. I'm not sure, do you use them or do you have a preference?
We don't have a preference, but then the lambda value, which is available from the mineral wools versus the cellulose, again, it's back down to the wall build-up. We need a wider wall build-up to achieve the same U value with cellulose as we would with our mineral wools.
Yeah. Someone is wondering, can you use the metal web joists in traditional construction projects, and do you fit them? If not, how are they fitted correctly?
We for a traditional build, yes, we supply to the market for metal web joists to them. We also would give a site fitting pack, which would detail hangers, fixings, centers, and in fact, most carpenters will be aware of how these are fitted, and again, how they're checked. Because we don't check to see that they're actually fitted. That will be down to whoever is dealing with your on-site quality, your architect, your engineer, whoever is signing off on your house should be in a position to check that. And if they're unsure, like we have often people come back to us, not sure whether it has been fitted right, we can give them 3D drawings. We have an availability on our system, which they can actually go into their own project and view it in 3D and scroll right in throughout it.
Yeah. Do you do many extensions to houses in timber frame, and is there any issue tying the timber frame back to the existing structure?
There's no issue tying them back. Again, each individual project is designed for its location, for how it's been fitted.
Yeah.
With extensions, we're to actually find the exact details, because we're a manufacturer off-site and with precision, to get the exact details of, say, fascia heights, wall plate heights to match in is the biggest issue.
Yeah. The steel frame portals you referred to for large openings, do you take responsibility for the design of the portals and the foundations? And there is another question about, I guess, how do you work with the I suppose the engineering consultant that's already on site?
If there's a steel portal required, whether it's to carry our structure or whether it's to carry our structure including blockwork, we will design that. We'll take account in, like, again, we're looking at fabric first. So if we can fit that within our stud and we can run our thermal insulation right throughout to achieve a full thermal break, the air tightness as well, we'll also do design. So it's most of the time where them posts are fitted, we have to fit the air tightness on site and we have to fit the thermal insulation on site. We fit these as part of our timber frame kit. And because we do a full design of it, we'll give line and point loads to the client or to the client's engineer, so they know what to design the foundations or footings underneath to take our structure.
Yeah. Can you calculate the fire resistance in Ireland? But I guess those are while the test, I know the test location is in the UK, but it is for the Irish market anyway.
Yeah, the fire tests we do are to an EN standard. The UK are still working off some of the BS British standard for fire tests, but they are tested in the UK because it's only recently in Belfast that there has been a test centre opened here. So some of the tests have been done in the UK and some of them actually have been done in Holland.
Very good. How does embodied carbon compare typical inner wall superstructure and timber frame superstructure? So, yeah, I guess a technical question that'd be hard to answer here, but yeah.
There hasn't been probably much analysis done on it. I've actually had a conversation with Jeff from Passive House yesterday regarding it. It's only now that probably councils and more people are looking towards that, because there's no, because we're not being penalized for using products that have a high cost to manufacture.
Yeah,
it would be commercially driven.
Yeah, I guess we're starting to see that now, isn't it? I mean, the request
there has been studies done in the UK from some of the housing associations and councils in the UK, which now we're starting to filter over to here.
Yeah, there's a little correction on the cellulose, the lambda value for cellulose. There is an Irish manufacturer producing cellulose at 0.034, so it can be right down there with some of the mineral wools. Last couple of questions. Speed of construction, cavity versus timber frame with external leaf cavity. Yeah, so traditional cavity wall versus the timber frame with the external leaf. And while you've gone through a lot of technical things today, Martin, that might be one of the main advantages.
Like speed on site for large developments is critical for their turnover overheads. But we've been on sites where they've been taken down. The scaffolding is fitted before we arrive, and it's just the base that's in, and they've taken down the scaffolding 4 weeks after we've arrived with our kit. So that means our kit is up, roof is on, felt and battened, roof tiles fitted, blockwork fitted on the outside, plastered, fascia soffit, guttering, everything down. So the speed of construction with timber frame does far exceed blockwork. And like probably the only thing that stops us on site fitting is wind.
Yeah.
Because we lift all with a crane, it's the wind that will cause us the greatest grief. Like you take earlier on in the year, there was 2-3 weeks there of very, very low temperatures, which blockwork couldn't be built, but we were still able to fit timber frame. And once the timber frame is fitted, we actually felt and batten, but the roof tiles can be fitted, windows can be fitted. It's wind and water tight, so your internal trades can start working away. So you're not restricted by the weather that's happening outside.
Yeah, so it should be a dramatic difference really in terms of completion times. Last question for the day, Martin. Do you provide the Y factor calculations for your units? I know it came up during the talk, and there's ACDs, but yeah, I guess how are you looking on the psi values or the thermal bridging modeling for the
Yeah,
all
we
typical
can provide
details?
them. There, some of them are work in progress, but like in the current ACDs, there's so many of them that will relate to easy build, but like the amount of other junctions which we would incorporate into ours, this, you know, it's probably it's a mix and a match of them.
Yeah. Martin, thanks so much. That's been fascinating, huge amount of information and detail provided. So just to confirm to everyone, there'll be a recording made available of today. We'd like to thank you all for attending, and thank Martin obviously for his time, and hopefully see you next Tuesday again. Thank you.
Okay.
Cheers. Thanks.
Thanks.